So that third one, you would type an 80 in, then you would hit this button, and then you would put an 11 in. So 80, choose 11. This one, real quick, we're not going to do this one. This isn't National Public Radio, but it's called Permutations. So if I pick U3, that's one pick. But the permutations would say I could pick you first, and then you, or I could pick you first, and then so that would count all the different reorderings. So NPR would be even bigger than NCR. NCR says it's the same group of people. What the shit are you doing, permutation? So we're going to use the third one. So how do I put this in officially? Go back to the normal screen. Quit. Put 80. Math. Probability. Number 3. If you have the newer calculator, it should look like this. If you have the older one, it'll just say NCR in the middle. 11. Enter. And just so you have, if you haven't seen this yet, that means times 10 to the. So it's 10 trillion, 477 billion. Oh, wow. Dead. I'm sorry. All right. So that is stupid big, right? I think we can all agree with that. Now, real quick, stay with me. Second. Oh, let's do this one real quick. What should 4 choose 2 be? 6. Let's try it. We do 4, math, probability, choose 2, 6. Good job, calculator. How many pizza topping choices are there, roughly? 12, 13. It depends on where you go, right? So say 12, and I can choose, maybe I want to make a 3-topping pizza. 220 ways to do that. All right, anyway. So, coming back. So if I look at this one again, I've got 80, choose 11, because that's the number that was missing right here, right? So the number that goes first is the number that represents how big the list would be. Because I would add each one of them, so of course I'm going to get that many of them. Then I got times p to the 11th. P was 0.27. And Q was 0.73. This is stupid big. Really big, stupid big, crazy big, whatever the shit kind of adjective you want to put there. It's a shit ton of things. And then this is going to be really, really small, because when you multiply a decimal times a decimal, it gets smaller. Because it's like 27% of 11 times of 73%, 69. It's going to be so stupid big times stupid small becomes normal. So I never have to look at this number by itself. I'm going to put the whole damn thing in so the calculator does it all for me at once. And I only have to see the nice number at the end. Let's try it. So we got 80, math, probability, 3, 11. Now here's something you got to be really careful about. I think you should be used to this by now with the newer calculator. You got to hit over to get back up, right? Because I was down there in the 11. I want to hit over, so I'm back up. Times point, what was it in? 27? 27 to the 11th. And again, got to get over to get the hell back down. Times 0.73 to the 69. And it becomes a nice, normal probability. I love that. Really stupid big, really stupid small, multiply, normal. Okay, maybe. I love you guys. You guys look unimpressed, but I'm not really sure what there is to be totally impressed by yet. Okay, so let's do one more example, and then I want to unleash you guys on a handout. Actually, I got to do a couple more things. What time is it? Oh, we got time. Good. Ha. So let's say the probability of what? I don't know. Probability of passing statistics is about 0.73. Huh? That's bad? You don't teach math, so you don't realize that's not bad. Remember this, what kind of sucks about, you guys don't want to hear all this, but we sort of have to prove that we're succeeding, and anybody who withdraws from a course is automatically counted as our failure. So that's in this too, right? And why do people withdraw from a course? Is it always because the teacher sucks or because they're doing bad? No, I get people that withdraw that are making A's because they have shit happen in their life. Anyway, sorry. I don't want to go off on a rant on that. Yes?
What's your actual passing grade?
It's close to it. Not mine. I'm talking about department-wide. Mine is nowhere near that high. No joke.
What is that?
No, it's about that. I love you guys. What does it matter? Right? You're your own person. Anyway, do you guys not know me well yet? How long have we been together? We've been together so long. Okay. Here we go. So what's the probability of not passing?
67.
Who? 27. I like it. All right. So let's say that I pick randomly 72 students. What's the probability that, what you got, Jeff? I don't know. Let's say, what's the probability that 58 of them passed? So let's see how to really attack this kind of problem. Let's see if you guys can identify. So what is N in this problem? What is N? 72. N, thank God, always means the same thing. The total number of things I'm working with. I'm working with 72 students. What's P?
58.
No. What does P mean? What is P in Q? What's P? Yeah, because P represents the probability of success. So it's got to be less than, or at most, 1, because it's a probability, right? I love you guys. So P and Q, what's true about P plus Q always?
1.
It has to be 1, because together they make up everything. Whatever one isn't, the other one is. They are opposite probabilities. So P is 0.73, so what's Q? 0.27. That's craziness. Now here's the other thing. I kind of made that number up, right? That's the question I'm asking. What's the probability that 58 of them passed? So what could that have been? What number could I have picked? Anything from what to what I could have picked? Even, I guess worse than that, 0 to 72, right? Because it could be nobody passes up to 72. You guys kind of with me? Yes. Yeah. Okay. All right. So guess what we call that then? The question number. Then that number, since it can change, it can vary. That's the variable. We call this X. X is the number of successes. So X in this case is going to be 58. So for this kind of problem, you want to first just identify those 4 things for yourself, because they all go into constructing the equation. This equation is almost too nice to believe. Let's see if you guys can put this thing together. How many people did I have total? 72. And I want to choose how many of them to do something? 58. So how many successes do I have? We just said it. Now, okay, the success is 0.73. And how many of them do I want? 58. So how many of these do I want? 14. I like it. Where the shit did 14 come from? Yeah, I got 72 people. 58 of them do this. So how many don't? The rest. So again, what must be true about the 2 coefficients? They have to add up to be the total. This is almost too nice to believe. Maybe not quite yet, but you got to see how this sets itself up. I got 72 total things. In this case, students. I want to choose 58 of them to do something. In this case, pass. So how many successes? 58. So how many failures? The rest. So I can make a different situation, but the idea of putting this together doesn't change. It's beautiful. All right, so let's figure this out, and then above this, I'm going to put the general formula. Notice that I didn't make a formula until we actually did a problem. So the formula is going to look a little worse than the actual construction, because the formula has to cover all possible situations. So how do I take a minute, try to put this in your calculator? Don't say anything out loud. Let's see if we all get the same thing. All right, what'd you guys get?
0.03865.
Yeah, that's what I got. So roughly this. How we all doing, you guys? Let me know if you need technical assistance. Okay. Yes. What will happen there? Somehow, I don't know what you did. So you do this. Make sure you come back up. Maybe that's part of it. See it had to come back up. And then you do. Yeah, that's looks like that's part of what happened. See that? To that, and then you have to come back down. Then you put 0.27 to the. Yeah. Cool. This. Everybody else, all right? Let's choose 50. G8 times. Just keep going. Colors. Times 7 to the 14. Oh, because I rounded, of course. Right next again. Yeah, that should work. Sweet. All right. Everybody else all right? Here, let's do one more. Let's see. Let's do another one of you. So let's say the probability that somebody finds a certain Easter egg is what do you got? 4.8. So it's probably they don't find it.
52.
And I want to know if I pick 39 people, what's the probability that exactly 21 find the egg? So how do you start off? What's n? 39. What's x? 21. What's p? 0.48. What's q? Yeah, 0.52. So try to set up the formula real quick. Yeah, maybe I'll do that. Yeah. So what we got? So probably x is 21. Is how many people are there? 39. And I want to choose 21 of them to find the egg. So I got how many of the 0.48s? 21. And how many of the 0.52s? 18. What's a real quick check I can make? This plus this? 39. And of course, please let them make sense. We have 39 people, and I'm putting some of them in one group and the rest of them in the other group. Okay. And let's see if I made one that comes out okay. So we put this in here, 39. Math, probability. No, Jeff. 39, math, probability. Number 3. 21. Come back up. Times 0.48 to the 21. Come back down. Times 0.52 to the 18. Bam! 0.0975. Poosh. Is that what you guys got? I like it. What if, all right, here's part A. What if I said part B is, you'll enjoy this. That's ominous. What's the probability that you could do it, Jeff? 19 or 20 people find it. What would you do? Yeah, how many formulas are you going to need to use? 2, because you got to figure out probably 19. Or means add, and then figure out probably 20 and add them together. Do you see why I kept saying from chapter 3, or means add, basically, and means multiply. So hopefully you multiplied in the first problem on the quiz. All those problems should have been multiplied to get the answer, because they were all ands. We'll find out. So I'd have to do a formula for 19. So I'd have to do 39, choose 19. I want 19 successes, and the rest will be failures. Or 39, choose 20. So I want 20 successes, and the rest would be failures. Nothing new. Or means add. I got 2 situations, so I got to figure out one situation out, the 19, plus the other situation, the 20. Yes?
So I know where like the exponent things come in the example before this, but how did where's I see it obviously it's like 19 and 20.
Yes.
But why is it that?
All right, this one definitely has to be 19, right?
Yeah.
Now this is the one piece of this. This sort of reads like an English sentence. And this is the one that's a little bit repetitive. 39, choose 19 of them to succeed. How many successes? 19. How many failures? The rest. Well, if 19 are here, how many are here? 39 minus 19, right? Is that all right? What's
Well,
up?
I was saying, so it's just okay, I understand.
Yeah, 39 minus this is the rest. And that's why these two will add up to be 39. I like it. Hey, Mikey. I'm not even interested in the answer to that. You can all plug it in your calculator. What I want to do is look at this to develop a formula. So if I have N, P, Q, and X, what's the formula for the probability of X? What was 39 in this problem? N. So it's the total number, choose X. Choose that many successes. So how many P's would I have? X. Now here's where it gets a little funkadelic. How many Q's would I have? N minus X. If I have X successes, I must have total minus X, N minus X failures. See how the formula makes it look worse than it really is. The coefficient, the exponent on the Q is just whatever's left over. How do I show that mathematically? Total minus part. Okay. I think I'm changing my mind here about doing this. We'll do this worksheet. I'm going to say this phrase. We're not done yet. We're going to do that worksheet next time. See that phrase, a part of our brain goes, oh, pack up, leave. Don't. Hold on. I got a little handout we'll do next time. I want to do one more thing with this stuff, and then I'll let you guys out. Okay. So, do you guys know Shaquille O'Neal? Anybody know Shaquille O'Neal? Not personally, but you've heard of it. So I know he was a Celtic. I'm a Celtics fan. It's been a rough road, but not as rough as the Lakers. But anyway, he was a Laker for most of his time. If you don't care about basketball, that's okay. Let's be really generous and say that the probability Shaq makes a free throw is 30%. So what's the probability he doesn't make a free throw? 70. That's roughly correct for his career, right? So now, let me just ask you. Let me just see if you get this. If he takes 20 free throws, how many would you expect him to make? How many free throws does he make? What percentage does he make all the time? 30%. So for any 20, how many of those should he make? 30% of 20, right? And so that's what you would expect him to make. That's the expected value for the number of free throws made. What's a shorter way to say expected value? Average. Remember that? So here's the best formula. Oh my God. Sorry. So every time we have a different way for them to give us data, I want a new way to figure out the mean and the standard deviation. These are the best formulas yet. The other ones we know, we need these tables and all this shit, right? Yay, tables and This one, we just did the average. You just did it. You got 6. How did you get it? 20% of, 20 times 30%. So 30% of 20, right? So what's the mean? It's going to be N times P. In this case, it would be 20 times 0.3. That's where you got 6 from. So you would expect him to make 6. If he made 7, would that be weird? No, right? Come on. Like if you flipped a coin 100 times, it's weird that you're sitting there flipping a coin 100 times, but you should probably analyze your life. But would it be weird if you got 49 tails, if you flipped it 100 times? No, because how many would you expect? 50, and 49 is not very far. Beautiful, right? So where does far, so 7 wouldn't be unusual. What about 8? What if he took 20 free throws and made 8? Would that be unusual? What's it feel like? Not quite yet. What if you made 13 free throws? That's kind of obviously would be, whoa, Shaq, good job there, man. Can you keep it up? No. All right. You guys got, right now we're just talking about, not even in this class, I could just talk about this normal. Well, maybe not all the time. So I need to know, what tells me how far things are in statistics? Standard deviation. And we know I always want to calculate the mean, the middle, and the spread. So the formula for the standard deviation, not quite as easy to explain as this, but here it is. Square root of NPQ. So let's see what that is. So it would be 20 times 0.3 times 0.7. It's going to be roughly 2.07. I don't know. Somebody can help me out. That'd be so cool if that was almost right. 2.07, maybe? It's probably more than that. 2.1 something? I don't know.
2.049.
Holy shit. I got pretty close. 2.049? All right. I like it. Okay, so there's our two formulas for a binomial situation to figure out the mean and the standard deviation. That completes chapter 4. Next time, the first thing we'll do is we'll work on this little handout that's got everything we've talked about from section 4.3, the binomial stuff. We'll do that next time. I'll have the quiz checked. Don't forget your various things.